So today we're working on predicting reaction products, and for most circumstances we're going to be predicting the products and balancing the reaction. For a lot of the transition metals, you should assume, if you do not know, that they make a positive 2 charge. Otherwise, if they have a known charge, so a metal like lithium or magnesium, then go with those charges. All right, so our first one up here is tin chloride. So tin, we're saying, has a positive 2 charge, so we would get tin chloride. So remember, this chloride is -1, tin has a +2, and then everything's 1 to 1 to 1. Then we have down here lead. We're assuming it is also lead 2 and chloride. So remember, +2 -1, so we get that, and it's a 1 to 1 to 1. We could get somewhere down here like barium oxide, and barium has a +2 charge. Oxygen has a -2 charge, so we're going to have to do some balancing. So if we have 2 oxygen here, we're going to have to 2 there, so we put the 2 out front here, which means there has to be a 2 in front of the barium. So today I'm just doing selected problems, so I'm going to head down to the next section, which is decomposition. So we have ammonia, and ammonia will break down into nitrogen, which remember is one of our diatomic molecules. So if you look back, we have hydrogen as one, and then, so remember that was our have, no fear of ice cold broccoli. So it makes this L shape down here plus hydrogen, upside down L, I guess. So we've got nitrogen, which was diatomic, hydrogen, which is diatomic, and then we need to balance. So if there's 2 nitrogen here, we need to have a 2 out front here, which makes 6 hydrogen, so we need a 3 here. So it's a 2 to 1 to 3. The next one is hydrogen sulfide. So remember, hydrogen's diatomic plus a sulfur, and this is a 1 to 1 to 1. Our next one is calcium oxide. So we have calcium plus oxygen, which is diatomic. So we need a 2 here, a 2 here, and a 1 in front of the oxygen. We're going to talk about magnesium sulfate in class today, so don't fret too much about that one. Moving down to single replacement. So we've got copper and silver nitrate. So here we're predicting the products, balancing them, determining whether a reaction occurs, and since we're doing single replacement, we're going to take a look at our activity series on our reference sheet. So we have copper and silver nitrate, which would make copper nitrate. So we can assume that this is copper 2, so we're going to have 2 of those, plus a silver, which would mean we would need a 2 out here, a 2 here, and everything else will be 1. So if we look at our activity series, we know that copper is above silver in the activity series, so therefore this does have a reaction. Yes, reaction. I know you can't see that. Woo! And then we need to assign our oxidation numbers. So elemental carbon would have, or copper would have an oxidation state of 0. Silver in this compound is +1. Nitrate is -1. Copper here is +2. Nitrate -1 still. And then elemental silver is 0. So if we have copper going from 0 to +2, it is losing electrons. So copper loses 2 electrons, which remember, if you do Leo, the lion says, grr, loss of electrons is oxidized. And then silver goes from +1 to 0, which means it's gaining electrons, or silver gains an electron, so it is reduced. And in this case, nitrogen is our spectator ion. We can go down to, let's see, let's do manganese and aluminum acetate. So this fun little thing here is an acetate ion, is same as this one down here. The other ones that are kind of weird are chlorate. So we would swap here. So we'd C2H3O2, and this has a -1 charge. We're going to assume manganese has a +2 charge. So that means we would have to have 2 there, plus aluminum. And to balance this, we would have to put a 3 out front here, 2 out front here, 3 out front here, and 2 out front here. So when we look at our reactivity, we need to look at manganese, which might be confused with magnesium. Manganese and aluminum. Manganese is actually below aluminum, so this reaction would not occur. But in our perfect world, if it did occur, we would say that this would be elemental for its oxidative state. This would be +3. This would be -1, -1, elemental. And we already have the +2 there. So manganese is going from 0 to +2, which means it is losing 2 electrons. So it is oxidized. And we've got aluminum, which goes from +3 to 0. So aluminum gains 3 electrons and is reduced. We can try a couple more of these. So let's do lead and aluminum sulfate. So we've got lead, aluminum sulfate. So there would be lead, sulfate. So sulfate has a -2 charge. Lead in this case we'll say has a +2 charge. And then we have aluminum. If we take a look at our reactivity series, aluminum is way ahead of lead. So we're gonna say that no reaction occurs. But in our fun-filled world, we're pretending one did, so we're going to balance this guy. So we're going to have a 3 out front here, which means we have to have a 3 here, and this is 1. So elemental would be 0 for our oxidative state, +3, -2, +2, -2, and elemental. So lead goes from 0 to +2, so it is losing 2 electrons, which means it is oxidized. And aluminum goes from +3 to 0, so it gains 3 electrons, which means it's reduced. And in this case, sulfate is our spectator ion. All right. See how much time I have left. Okay, I'm going to the next page real quick. Got a double replacement reaction. So in this case, remember the positive ion switch partners. Double replacement reactions, we aren't going to see a redox reaction occurring. The oxidative state should stay the same. So we have barium chloride and sodium carbonate. So we get barium carbonate plus sodium chloride. And both of these are 1-to-1. So barium has a +2 charge here, chlorine has a -1 charge. So there's a 2 here, but when you get over to this side, sodium has +1, chlorine has -1. Barium has +2, carbonate has -2, so that's neutral. So we're gonna have to have 2 sodium chlorides, which means that everything else is balanced. Sweet. Now we need to look at our solubility. So we're looking for barium carbonate and sodium chloride. We know sodium chloride is aqueous, but how about barium carbonate? So we go to barium, we go to carbonate, and it makes a solid. So that means a reaction has occurred. Yes, reaction. We go down here to nitric acid and sodium chloride. So we get hydrochloric plus sodium nitrate, and these are all 1-to-1. So the equation is already balanced. If we look up hydrochloric, it is aqueous, and sodium nitrate is aqueous, so no reaction is occurring here. on down a little bit further, maybe potassium sulfate and magnesium fluoride. So we would get potassium fluoride and magnesium sulfate. Again, these are 1-to-1s. We're going to have a 2 out front here to balance the equation. If we look, potassium seems to be aqueous all the way across, so we don't need to worry. Magnesium and sulfate are also aqueous, so there is no reaction. All right, and finally we've got some combustion going on. So remember, combustion, we're always going to get carbon dioxide and water. So let's balance this guy. So we've got 12 carbons, so we can put a 12 out front here. We've got 22 hydrogen, which means we need an 11 out front here. And then we have 11 plus 24 is 35. We've got 12, but we can't make an odd number of oxygen because we'd have to have here. So we're going to do, let's see, 35 minus 12 is 23, which would make this 11.5. So if we double this, so 23, 2, 24, and 22 should be balanced.